Crystal. In today's video, we're taking you inside the entire process. Welcome to Factory Founder, where we explore the biggest factories, the most powerful machines, and the incredible industrial processes that keep the world running.
Deep beneath the vast deserts of the Middle East lies one of the most valuable resources on Earth, a thick, dark liquid formed over millions of years from ancient marine organisms buried under layers of sediment and rock. This substance is crude oil. Every day, millions of barrels of crude oil are extracted from underground reservoirs and transported across oceans to power the modern world. Oil fields are often located in remote desert regions where no infrastructure exists. Trucks haul tons of gravel and compacted soil to create stable surfaces for drilling rigs that can weigh hundreds of tons. Workers carefully level large sections of land to prepare drilling pads. Reinforced foundations where drilling rigs will operate for months. Surveyors use advanced geological data and satellite mapping to identify the precise location where drilling should begin. Every meter matters because deep beneath the surface lies a complex network of rock layers that must be reached with extreme precision. Once the site is prepared, the real work begins. At the center of the operation stands a towering rotary drilling rig. These enormous machines are capable of drilling several kilometers beneath the surface of the Earth. A powerful rotating drill bit, made from hardened steel and industrial diamonds, begins cutting through layers of rock, sand, and shale. As the drill penetrates deeper, a thick fluid known as drilling mud circulates continuously through the drill pipe.
Drill speed is critical. Maintaining pressure.
Copy that. Monitoring levels on the rig.
Watch for flare-ups.
This mud performs several critical functions. It cools the drill bit. It carries crushed rock fragments back to the surface. And most importantly, it stabilizes the walls of the well to prevent collapse. Drilling operations continue day and night for weeks or even months. Every few hundred meters, steel casing pipes are inserted into the well to reinforce the structure and isolate different geological layers. These casings are permanently cemented into place, creating a strong barrier that protects underground water sources and prevents leaks. Finally, after thousands of meters of drilling, the drill bit reaches the target.
Adjusting the chemical feed rate now.
Specialized equipment called perforating guns are then lowered deep into the well. These tools create tiny holes in the casing, allowing crude oil trapped in porous rock formations to enter the well. At the surface, a large assembly of valves and pressure control equipment known as the wellhead is installed. This system controls the flow of oil from underground and ensures safe operation under extremely high pressure conditions. With the well completed, production can finally begin. In some reservoirs, underground pressure is strong enough to push oil to the surface naturally, but in many cases, artificial lifting systems are required. One of the most recognizable pieces of oil field equipment is the pump jack. The large mechanical structure often seen slowly rocking back and forth across oil fields. This machine converts rotary motion into vertical pumping action, pulling oil up from deep underground. In deeper wells, electric submersible pumps are installed thousands of meters below the surface. These powerful electric pumps push oil upward through steel tubing at high pressure. Once the oil reaches the surface, it enters a network of pipelines and gathering systems that transport it to the next stage of processing. But the crude oil coming out of the ground is far from pure. It contains gas, water, and sediment that must be separated before further transport. Freshly produced crude oil is a mixture of several substances. Natural gas bubbles inside the liquid, water from underground reservoirs mixes with the oil, and small particles of sand and sediment are suspended within the flow.
The gauge on the right seems to be fluctuating slightly. Notice that, just check the valve, should stabilize now.
To handle this mixture, oil fields use large industrial separators. Inside these massive cylindrical vessels, the mixture is allowed to settle. Because gas is lighter than oil, it rises to the top and is captured separately. Water, being heavier than oil, sinks to the bottom. The oil itself forms the middle layer. This process is known as three-phase separation. The separated natural gas is often compressed and transported through pipelines to processing facilities. The water is treated and either reused or safely disposed of. The crude oil then moves to storage tanks, where its volume and quality are measured before transportation. Before crude oil can be sent to refineries, it must undergo additional treatment. The oil is passed through filtration systems to remove remaining solid particles. Next comes dehydration, where specialized equipment removes leftover water. One of the most critical steps is desalting. Crude oil often contains dissolved salts that can damage refinery equipment through corrosion. To remove these salts, the oil is mixed with fresh water and passed through electric separators that pull salt particles out of the mixture.
Analyze the naphtha sample. Input the viscosity data into the system. Check the flash point again, it seems off.
Finally, the crude oil is heated slightly to improve its flow properties. Now the oil is ready to begin its journey across the world. From the oil fields, pipelines carry crude oil to massive coastal export terminals.
Line pressure is steady. Copy that. Transfer initiated.
Here, giant storage tanks hold millions of barrels of oil awaiting shipment. At the docks, enormous tanker ships, some of the largest vessels ever built, arrive to transport the oil across the globe. Flexible loading arms connect the pipelines to the tanker's cargo system, transferring thousands of barrels every hour.
Pressure is stable. Check valve 4.
Once loaded, the tankers begin their journey through one of the most critical shipping routes in the world, the Strait of Hormuz.
Copy that. Proceeding. Status secure at the main manifold.
This narrow waterway connects the Persian Gulf to the open ocean and carries roughly 1/5 of the world's oil supply. Every day, dozens of massive tankers carefully navigate through this busy channel. From here, the oil travels to refineries in Asia, Europe, and beyond. But the crude oil still cannot be used directly as fuel. For that, it must undergo one of the most complex industrial processes on Earth. Oil refineries are massive industrial complexes designed to transform crude oil into usable fuels and chemical products. The first stage of refining begins with heating the crude oil. Inside giant furnaces, the oil is heated to temperatures approaching 400 degrees Celsius. This hot mixture is then fed into a towering structure called the atmospheric distillation column. Inside the column, the heated oil separates based on boiling point. Lighter substances rise toward the top, while heavier ones remain lower in the column. From this single process, several important products are produced. At the top, light gases become liquefied petroleum gas, or LPG. Slightly heavier vapors condense into naphtha, which is later used to produce gasoline. Further down the column, kerosene is collected, the fuel used in jet aircraft. Below that comes diesel fuel, essential for trucks, ships, and heavy machinery. At the very bottom remains a thick substance known as atmospheric residue. But even this heavy material still contains valuable hydrocarbons. So, the refining process continues. To process the remaining heavy residue, refineries use another towering structure known as the vacuum distillation unit. By lowering the pressure inside the column, engineers can separate heavier hydrocarbons at lower temperatures. This prevents the molecules from breaking down due to extreme heat. From this stage, new products are extracted: vacuum gas oil, which will later be converted into gasoline and diesel through advanced chemical processes. Many modern refineries use additional units, such as hydrocrackers and catalytic reformers. These advanced technologies break large hydrocarbon molecules into smaller ones, creating more valuable fuels. From one barrel of crude oil, refineries can produce dozens of different products. The refined products are stored in massive tanks before being transported through pipelines, trains, trucks, and ships. Gasoline powers billions of cars around the world. Diesel fuels trucks, ships, and heavy equipment. Jet fuel keeps aircraft flying across continents. And petrochemicals derived from oil are used to create plastics, medicines, synthetic fabrics, and thousands of everyday products. All of it began deep beneath the Earth's surface. From remote desert drilling rigs to towering refinery columns, to giant tankers crossing the oceans, the journey of crude oil is one of the largest industrial operations ever created by humanity. Every barrel represents an extraordinary chain of engineering, logistics, and technology working together on a global scale. A hidden network that powers modern civilization. And it all begins with a single drop of oil buried deep beneath the desert.